Today, we're immersing ourselves in the dynamic realm of real-time data processing, guided by technology that has truly transformed the landscape of distributed systems. Apache Kafka isn't just a tool, it's a powerhouse reshaping how we navigate and manage data streams. Whether you're a seasoned developer, a data engineer, or someone simply captivated by cutting-edge tech, this tutorial is your golden ticket to unlock the core concepts and capability that Kafka brings to the table. In this video, we're embarking on a journey to unravel the intricacies of the Kafka ecosystem. We'll explore the nuance of Kafka clusters, producers, consumers, and topics, venturing into the dynamic universe of partitions. Additionally, we'll delve into the collaborative efforts of consumer groups, unravel the magic of offsets, and demystify serialization, a pivotal element in Kafka's enchanting data sorcery. Here our agenda for today's exploration. Understanding the fundamentals of Message Broker and uncovering its advantages. Immersing ourselves in the Kafka ecosystem, breaking it down in components and building blocks. Then, we will explore the intricacies of a Kafka cluster, Kafka Broker, Kafka Producer, and a Kafka Consumer. And then, demystifying the concepts of Kafka Topics, Partitions, and Offsets. Then, investigating how multiple customers collaborate for enhanced performance. But we're not stopping at theory. We'll put these concepts into practice by first showing and guiding you step by step how to install Kafka and navigating through the fundamental elements of the Kafka. Then, harnessing the power of Kafka within Spring Boot framework to send and consume data. And I will show you how we configure topics, how we can configure Kafka for a producer, for a consumer, how to send data and how to consume data. And now envision this captivating scenario. A continuous stream of data orchestrated by a reactive Spring Boot producer, seamlessly delivering messages to a Kafka broker. Now, picture a diligent consumer meticulously transcribing these messages into enchanting realm of DynamoDB. Exciting, isn't it? So stick around because this journey is about to become even more captivating. Whether you're a seasoned developer or a newcomer to the realm of real data, this tutorial is meticulously crafted to keep you engaged from the beginning to the end. I guide you through each step, demystifying Kafka's concept, and by the conclusion of this video, you'll wield Kafka powers with the confidence. But before we dive in, do me a quick favor. Hit that subscribe button and ring the notification bell and help this channel grow more and more. You don't want to miss the incredible tech content I've got lined up for you. Also, be sure to check out my website for additional courses and resources. So let's stay connected on social media. All the links are conveniently placed in the description of this video down below. So grab your tech gear, brew a cup of coffee, and let's embark on this exciting Kafka adventure together. Our code is ready, the data stream is flowing, and we're on the verge of unlocking the secrets of Apache Kafka. So let the journey begin. First, let's understand what is a broker. So a message broker, like we see here, we have Apache Kafka, Amazon SQS, and RabbitMQ. All these are classified as message brokers. So a message broker is an intermediary software component responsible for facilitating communication and data exchange between different applications or systems. So its primary function is to decouple producers, which are the application that send the data to the broker, from the consumers, which are the application that receive the data. So the message broker acts as a mediator, ensuring that messages are delivered efficiently and reliably from producer to the consumer. And the key characteristics of message brokers are first we have decoupling. So the message broker enable loose coupling between the application by allowing them to communicate without needing to be aware of each other's existing. So here we have the left hand side will send the message to the broker, and the right hand side will consume the message from the broker. So we don't need to know who sent this message. Then we have an asynchronous communication. So message brokers often support async communication, allowing producers and customers to operate independently of each other's timing and availability. And then we have scalability. So message brokers can be designed to handle large volumes of messages and scale horizontally to accommodate growing workloads. And finally, reliability. They often provide mechanisms for ensuring message delivery and reliability even in the face of system failures. So this is a global overview of a message broker. Now let's see what is Apache Kafka, which is the topic of today's video. By having a look at this diagram, so this is a global overview of the Kafka ecosystem. So first of all, Apache Kafka is a distributed, fault-tolerant, and highly scalable message broker and stream processing platform. It was originally developed by LinkedIn and later open sourced by an Apache Software Foundation project. So Kafka is designed to handle large volumes of data streams in real-time and fault-tolerant manner. And here let's have a look on the key components of the Kafka. So first we see here we have producers. So an application that publishes message to the Kafka topic. Then we have on the other side we have consumer or consumers. So the consumer is just an application that subscribes to the topic and processes the published messages. Then we have a broker. So here a broker or a Kafka broker form the core of the Kafka cluster. So storing and managing the streams of records. Then within a broker we have topics. So a category or feed name to which records are published. So topics in Kafka are used to categorize messages. Then we have also, we will see this later on, we have also partitions within Kafka. So topics are divided into partitions, allowing Kafka to parallelize processing and scale horizontally. Then we see here that we have something called Zookeeper. So the Zookeeper or Kafka relies on Apache Zookeeper for distributed coordination of and management of the Kafka cluster. So the Zookeeper, we will explain it more in details just in a few moments. Its main role is to manage these brokers. Kafka comes with many advantages. So first, Kafka can scale horizontally by adding more brokers to the cluster, providing high throughput and low latency data processing. Then we have durability. So messages in Kafka are persisted to disk, providing durability even in the event of node failures. Then it's fault tolerant. So Kafka is designed to be tolerant, ensuring that it can continue to operate seamlessly in the face down of hardware or software failures. And then it's a real-time processing. So Kafka allows for real-time stream processing, making it suitable for applications that require low latency data delivery. And then, as we spoke before, decoupling. So Kafka topic-based architecture enables decoupling between producers and consumers, allowing flexibility and independence in application development. Then we have the data retention. So Kafka provides configurable data retention policies, allowing organizations to retain messages for a specified period. And finally, it's the ecosystem integration. So Kafka has a rich ecosystem with connectors for integrating with various data storage systems, stream processing frameworks, and analytics tools. Now let's break down the Kafka components. And let's start with the Kafka cluster. So within the context of Kafka, a cluster is a group of brokers or we also call them servers, working together for three reasons. First, speed, or we also call it low latency, and then durability and scalability. So several data streams can be processed by separate servers, which decreases the latency of data delivery. Data is replicated across multiple servers or brokers, so if one fails, another server has the data backed up, ensuring scalability, meaning durability and availability. So Kafka has also balances to load across multiple servers to provide scalability. So to resume, a Kafka cluster is a group of one or more Kafka brokers, also we call them servers, working all together to manage the storage and exchange of data in the form of messages. So Kafka is designed to operate as distributed system, and a cluster allows it to scale horizontally, provide fault tolerance, and handle large volumes of data across multiple nodes. So Kafka brokers are servers with special jobs to do. So managing the load balancing, replication, and stream decoupling within the Kafka cluster. So the question is, how do they get this job done? So, well, first of all, in order to start a Kafka cluster, so the developer authenticates to a bootstrap server or a few of them, and they will show you that within the code later on. These are the first servers in the cluster. Then the brokers also balance the load and handle replication. And those two features are key to Kafka's speed, scalability, and stability. So, autrement dit, a Kafka broker is an individual Kafka server that stores data and serves client requests. Brokers within a cluster communicate with each other to ensure data replication and maintain cluster metadata. And each broker in a Kafka cluster is assigned a unique identifier. The next block is simply a producer. So a producer is one of the simplest building blocks of the Kafka ecosystem. So in Apache Kafka, a producer is a client application that publishes or writes events to a Kafka cluster. So the producer can be a Java application, PHP, .NET application, or any other type of application, even a command line, and it simply writes or sends an event to a Kafka cluster right here. So this is the definition of a producer. Now let's move on and see other building blocks. So back to this one, we said that a producer is the one who sends the message or writes the event. So the consumer is from the other side, is the application or the system that consumes or subscribes to the topic or the Kafka cluster in order to consume the events. So autrement dit, consumers are applications or systems that subscribe to Kafka topics and process the messages, and consumers can be part of a consumer group, allowing them to parallelize the processing of messages. So this is the definition of a customer. Now, let's move on to the next part. We mentioned many times the keyword topic. So let's see what is a Kafka topic. A Kafka topic is a logical channel or feed category to which records or messages are published by producers and from which records are consumed by consumers. So topics, they serve as a way to organize and categorize the system of messages within the Kafka messaging system. Autrement dit, in Apache Kafka, a topic is fundamental abstraction that represents a category or feed name to which records or the messages are published by the producers and from which records are consumed by consumers. So topics play a crucial role in organizing, categorizing the flow of data within a Kafka cluster. So they provide a way to structure and manage the data streams, allowing for the separation of concerns in a distributed and scalable manner. Then, when we talk about topics, of course, we cannot skip talking about partitions. So in Apache Kafka, a partition is a basic unit of parallelism and scalability. It is a way of horizontally dividing a topic into multiple independently managed units. Each partition is a strictly ordered, immutable sequence of records, and it plays a crucial role in the distribution, parallel processing, and fault tolerance of data within a Kafka cluster. So as always, autrement dit, so partitions are a crucial concept that allows for horizontal scaling and parallel processing of data within a topic. So a topic can be divided into multiple partitions, and each partition is linear, ordered sequence of records. Understanding partition is key to leveraging the scalability and performance benefits of Kafka. So now let me tell you about some key aspects of partition in Kafka Topic. So first of all, partitions enable parallel processing of data. Each partition can be thought of as an independent stream of messages. So producers can write and consumers can read from different partitions concurrently, allowing Kafka to handle a higher volume of data by distributing the workload across multiple partitions. So then Kafka achieves the scalability by distributing partitions across multiple brokers and allowing each broker to handle a subset of the partitions. As the data load increases, you can add more brokers to the Kafka cluster, and the partitions are automatically reassigned to maintain load balance and improve the throughput. And messages within a partition are strictly ordered based on their offset, which is a unique identifier assigned to each message in the partition. This ordering is guaranteed per partition, but not across partitions. Once a message is written to a partition, it becomes part of an immutable log. So this characteristic simplifies data processing and ensures consistency within a partition. Next, let's see how this offsetting works. So when we talk about partitions, we also talk about offsets. So an offset is a unique identifier assigned to each message within a partition in a Kafka topic. So it represents the position or location of a message in the partition's log. So offsets are used to track the process of consumers and enable them to resume consumption from a specific point, even in the event of failure or restart. So here, let me give you some key points in order to understand better the offsets. So first, we talk about unique identifier. So each message within a partition is assigned a monotonically increasing offset. So the offset is unique across partitions or topics. So one here, we can find it across many partitions. So it's not unique across partitions, but unique only within one single partition. Also, they have a sequential order. So offsets are assigned in sequential order as messages are produced to a partition. So the offset of a message is determined by its position in the partition's log. Once assigned, the offset of a message is immutable. It does not change over time, even if other messages are produced or consumed in the partition. And finally, the consumer progress. So consumers in Kafka keep track of their process by maintaining the offset of the last processed message in each partition. So this allows consumers to resume consumption from the point where they left off, ensuring that no messages are missed. So now let's picture together how offsets works. So first, let's get it from a producer perspective. So when a producer sends a message to a Kafka topic, the message is appended to the log of the appropriate partition. So the producer receives an acknowledgement once the message is successfully written to the partition. At this point, the message is considered to have an offset. All right. So then from the consumer perspective, so consumers, they track the offset at the last processed message in each partition they consume from. As a consumer process messages, it updates its offset to reflect the position of the last successfully processed message. The offset is committed to a special Kafka topic called consumer offsets topic. So this topic stores the mapping between consumers groups and their committed offsets. So now, in the event of a consumer restart or failure, the consumer uses the committed offset from the special Kafka topic called consumer offset to determine the last processed message for each partition. So then the consumer resumes consumption from the stored offset, ensuring that it continues from the point of the last successfully processed message. Finally, let me explain the offset committing. So consumers can write offsets periodically or after processing a batch of messages. This commit operation updates the stored offset or the Kafka special offset called the consumer offset topic. So Kafka provides different mechanisms for offset committing, such as automatic committing or manual committing, depending on the consumer's configuration. All right, so we spoke about consumers and we mentioned this word many times, and we also in the beginning we spoke about consumer groups. So next, let me explain to you in details what is a consumer group. Now let's talk about consumer groups in Apache Kafka. So consumer groups are a mechanism designed to enable parallel and scalable processing of messages across multiple instances of a consumer application. So consumer groups allow a set of consumers to work together to consume and process messages from one or more partitions of a topic. So this concept is particularly useful for achieving high throughput data processing and load balancing in distributed systems. Autrement dit, a consumer group is a logical grouping of Kafka consumers that work together to consume and process messages from one or more partitions of a topic. So each partition in a topic can be assigned to at most one consumer within a consumer group. So as you can see in here. So this ensures that each message within a partition is processed only by one consumer at a time. Consumer groups are especially beneficial in scenarios where there is a need of parallel and scalable processing of large volumes of data. Also, where we have a high throughput data streams need to be distributed and processed concurrently. And finally, where load balancing across multiple consumers is essential for efficient resource utilization. Now let's get started with Apache Kafka and let's have a first hands-on. So the first thing that we need to do, just go to open the browser and navigate to the URL kafka.apache.org or just type in Google Apache Kafka. So then open this link and here you will land on this landing page. So here you see that this is a brief definition of Apache Kafka, saying that Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integration, and mission critical applications. And then you can also have a look at the rest of the website. For us, the most important part is to start or download Kafka. But to do that, just go to get started and then quick start. So here you can also watch this video and then just scroll down. The first step is to get Kafka. So in order to get Kafka, click on this download link. It will navigate you to a different page. And here you can download the recent or the most recent version. So for today, at the time and the date of recording this video, so the version is 2.13.360. All right. So now assuming that you clicked on this one and downloaded already this zip file, let's go back and follow the rest of the steps. So the first thing that we need to do is to extract this zip folder. So I already downloaded Kafka and it's already here. So just double click in order to unzip it. And here, just for my case, I will just call it Kafka_server, just in order to be easier for me to navigate through the terminal or the command line. So next, we need to start the Kafka environment. So in order to do that, we need to start our zookeeper. So in order to do that, we need our terminal and we need to navigate to the path where we extracted Apache Kafka and simply run this command. Alright, so on the terminal, make sure that you are on the root folder where you extracted the Kafka server, and to make sure, just run the command ls, and here we see that we have the zip file and also the folder where we extracted. So first, let's navigate to the Kafka server folder, and in here we will run the first command that we have in this documentation. So I will just copy this one, and then I will run it in order to start the zookeeper service first. So let's paste it here. And now, just in case you want to see what do we have inside this Kafka server. So here we have this bin folder where we have all the shell scripts, all the scripts, and also here for the Windows users, you have this Windows folder. So in this folder also you have all the bad scripts, so you can run them instead. So this bin folder is compatible with Mac and Linux, and also for Windows users you need to navigate to the Windows folder in order to be able to run this command. So you need to change your path accordingly depending on your operating system. Alright, so now let's go ahead and run this command and see what will happen. So here we need to make sure that everything started without any exceptions, without any errors, which is the case that we have right here. So we don't have any exceptions and everything is up and running with the zookeeper. Now let's go back to the documentation and let's check the next step. So then we need to open another terminal session and run this command. So I will go back to my terminal and I will open a new tab, or you can also open a new terminal instance and run this one. So here on this instance, I'm also again in the Kafka server folder. So I will paste the command to run the Kafka servers. So hit enter, and here let's make sure that everything is up and running. So as you can see from the logs right here, everything is up and running and we don't have any exceptions. In case, for example, if the port is already used, or if you have another instance running and so on and so forth, so you will face an exception, and depending on the exception, try to solve it. And just in case you can't solve it, just paste in the comment down below, or just paste your issue on our Discord server and you absolutely will get help. So as you can see here, the Kafka server is already started on the port 9092, which is the default port for the Apache Kafka Broker. So now let's explore a little bit more Kafka. So we will go back to the documentation in here. So then we can create a topic to store events. So all we need to do is to copy this command right here. So I will copy it, and then I will open a new tab in my terminal and run this command. So I will paste this command. So this Kafka topics, and then we have this argument create, and we want to create a topic. Let's call it quick start event. And then we need to precise the bootstrap server, which is our localhost 1992. So pay attention to these arguments because we will need them later on when we start our Spring application. So let's hit enter in here. So here it says that created topic quick start event. So now let's go back and see what are the next steps in order to publish some events and to consume them later on. So here, as a next step, we can also describe the different topics that we have. So let's copy also this command and see what are the topics that we have. So for example, here I will create another topic and I will call it, so for example, I will call it test topic. And then I will describe or list the list of the topics that we have in our broker. So now I will paste the command that I already copied. So Kafka Topics, and then describe the topics. And here, so we want to describe, for example, the quick start event. And if I hit enter, it will give us the details of this event. If I run this command again and put the test topic, it will give us also the information of our test topic or the second topic that we created. All right, after that, let's try to write some event or to push some messages to our broker by pushing them to this topic or the quick start events topic. So let's go back to the documentation and follow along. So here, to write some events into the topic, we already have a script provided us by Kafka that we can use to publish some events to some topic. And as you can see here, so we have this command. I will copy it here, and then let's explore it together in the command line. So now if I paste this one, you will see that we have this command. So it's using the Kafka console producer sh. So this is the script, and we want to publish to the quick start events. So this is our topic, and here we have our bootstrap server, which is the one that we just started before. So I will hit enter, and then we will be prompted, and now we are able, or we will be able to publish any events. So here, hello, this is my first message, for example, and then hit enter. So this one was already queued to the Kafka topics. Now let's go back to the documentation and see how we can consume a topic. So now, in order to read the events, I will copy this one, and then I will open a new tab in my terminal and I will consume it. Because I don't want to exit this one, I will publish other message in just a few seconds. Alright, so now in this new tab, as you can see here, we have also a script. It's called Kafka Console Consumer, and here we need to precise the topic, which is the quick start events, the one that we already published on it in here. So also from beginning, we want to start consuming from the beginning, and here we have the bootstrap server, of course, that we need to precise. So now if I hit enter, so you see that here we have, hello, this is my first message, and this consumer is already listening. So in case I just type a new message, so this is a new message, and I hit enter, and if I go back here, you will see that it's already displayed in here. So you can have your terminal like both instances, one next to the other, and once you push an event here, so hello again, I will try to go fast to show you. So here I publish, and now it will pop up, as you can see in here. So this is how we can publish, and how we can consume also an event. So all this is already in the quick start. Also, you can follow along, and you can see the other different options that you can use from this documentation. Now let's move on to see how we can implement or how we can use Kafka within a Spring Boot application. And finally, don't miss out the rest of the video, because we will be implementing a really nice application using Spring Boot Reactive, and we will be consuming a Reactive REST API, and we will be publishing everything to our Apache server and consuming the messages from there. Alright, now let's go ahead and create a new Spring Boot project. So in order to do that, just go to the Spring Initializer, or you can also use your IDE, IntelliJ or Eclipse in order to create a new Spring Boot project. So here, first I will choose a Maven project, Java language, and then the latest version, which is 3.15. And now I will provide the group ID, which is com.alibu, and then the artifact, I will say just Kafka-demo. Alright, so here the name would be Kafka Demo, and here Spring Demo project for Spring Boot and Kafka. And here I will just call the package Kafka instead of Kafka Demo. Alright, so now we need to add a few dependencies. First, let's start with Lombok. And then we need Spring Web in order to expose our REST API and to be able to send and consume messages. And finally, we need to search for Kafka. And here you have two dependencies. Choose the first one, which is Spring for Apache Kafka. All right, so now you have your project. Go ahead, click on generate and open it within your IDE. All right, so now I have my project open and ready. So I opted for the monorepo approach. And here you see that we have this Kafka demo project, and then we will be adding other projects when we move to the final application demo that we will implement together. So here for the Kafka demo, here let's go first and check our resource file. So here we have our properties, and I prefer using YAML representation, so I will just switch it to YAML. And now let's add a few configuration. First, we need to configure the Kafka server. So here we have spring.kafka, and then we have consumer. So we want to give the configuration for our consumer first. So, and then we need our bootstrap servers. So here, as you can see, we can provide multiple servers, not only one. And for that, remember from the command line, it was localhost and then the port 9092. All right, so next, as you remember, when we explained in this diagram, we said that a consumer is a part of a consumer group. So now we need to tell which consumer group we want to create. So we can create multiple consumer groups, but for now, let's just go ahead and create a group ID. And here, let's give it, for example, my group just for start. Then we also spoke about offsets, we spoke about partitions, and so on and so forth. So now also we need to give another property in order to tell Spring what we need to do when, for example, we lose the offset or we want to reset the offset. So here we have a property called auto offset reset. So here we want to say what we want to do in case we lose the reset or we want to reset our offset. So here you see that we have several options. We will be using the first one, which is the earliest. And as you can see here, it automatically resets the offset to the earliest offset. And here we also have exceptions, so it will be throwing an exception to the consumer. Latest will be automatically reset the offset to the latest offset, and none if we don't want to opt for a reset offset. So let's choose earliest in here. And then, as you can see in here, so this is like the update of our offset. So this is what we made. And now in order to consume a message, so the message will be serialized from the producer. And when it comes to the consumer, we need to deserialize the message. So we have serialization from the producer part and deserialization from the consumer part. So this is what we will be providing as properties right now. So here, let's say we have a key deserializer. So because the message will be like a key value, so we will have a key and a value. So the key in this case, we will use the org.apache.kafka, and then we have common. It's a package called common, and then serialization, and then dot. So for now, we will start with a simple example, we will be sending strings and consuming strings. So we will be using a class called string deserializer. All right, so let's duplicate this line. So here, as we can see, we have key serializer. Now we need to provide the value deserializer, sorry. So here is the same way. We will be using the same deserializer, since, as I mentioned, we will be in the first example sending only strings, and then we will see another example if we want to send and receive JSON objects, for example. Now, this is the configuration for our consumer. Let's go ahead and configure our producer. So for the producer, also we need to tell what is the bootstrap or what are the bootstrap servers. So here, don't worry, in this demo project, it will be the producer and the consumer at the same time. But later on, we will be creating a full application where we will be implementing an application, and we will have an application as a producer and another application as a consumer. So now it's just for demo, just to get you started with Apache Kafka. So here, imagine now we are on the producer project or the producer application, and we are configuring the producer. So here, this part, you put it only on the consumer project, and this part, you put it on the producer project. So here, let's go back and finish the implementation for our producer. So in the same way, here we need to tell, or we need to provide the bootstrap servers, which is the same one as in here, since we'll be sending to the same broker. And then also we need two properties, these ones. So I will copy them and then I will paste it. So we have the key. Now it's not serializer, but it's deserializer. All right. Sorry, it's the other way around. It's not deserializer, but it's a serializer. As I mentioned before, when we send an event, or when the producer sends an event or pushes a message, it needs to be serialized, and the consumer needs to serialize it, to deserialize it. So it's the key serializer and the key and the value serializer. And here you need to be careful about this point. So for example, the producer, if the producer sends a string, you also need to have a string deserializer, but just you cannot, for example, send another type of data serialized and then you try to deserialize it using a different deserializer. All right, so now we have our configuration for our consumer and our producer. So we can just try and click start the application. Let's enable annotation processing for Lombok, and here we just need to make sure that the application is up and running, which is the case right here. So for example, here we did not provide, for example, something wrong, and here just we need to pay attention to some property. As we mentioned here that it's a key serializer, also this one needs to be string serializer, not deserializer. So also you need to be careful about this point right here. So I will stop the application, and now let's move on to the next part. After providing the Kafka properties, the first thing that we need to do, we need to create our topic. So the first thing, let's right click here, Java class, and I will put it in a config package, and then I will call it Kafka Topic config. So Kafka Topic config. So here, this one, in order to make this a configuration, as you know, within Spring Boot, we need to mark it as configuration. And then what we need to do, we need to provide a bean of type topic in order to create a topic. So here, let's use the bean annotation, and then let's create our bean, which will be of type new topic. So this means that we want to create a new topic in our Apache Kafka message broker. So let's call it, for example, Alibu topic or my topic, or you can call this bean wherever you want. So now we need to provide, or we need to return an object of topic builder. So we have a class called topic builder, and then we just give it the name. So this will be the name of the topic, and here let's call it Alibu, for example. And within this builder, we can also provide other information. And among these informations, since we said, and as explained before, a topic is already composed of several partitions. So here you can say, for example, I want to have, for example, let's say 5 partitions. Also, we can have some replicas and so on and so forth, but this will be our own configuration. And also we can leave all this to Kafka in order to have the default configuration from Kafka. So then we just need to provide the name in order to build a default topic. We just need to provide the name and then call the build method. So this way, we just created a new topic called Alibu, or also you can call it, for example, Alibu topic, or anything you want. So the next step is to create a Kafka producer. So we need to create the producer class that will send, or that will queue a message to our broker. Now I will right click in here and create a new class, and I will create a package called producer, and then I will create a class called Kafka Producer. And now what we need to do, first we need to mark this class as a Spring component or Spring bean. So we can use, for example, the service annotation, or we can also use the component annotation or any other custom annotation you want to create. Also, I will be using the required args constructor in order to have a constructor with parameters, or with the required parameters that I want to. So the first thing we need to do is we want to have a private final, and then we have an object or a bean called Kafka template. So this Kafka template is already a generic one, and it takes, let's download the source, and as you can see here, it takes a key and a value. So here the key type and the value type, and this one, if you remember the configuration that we created together for our producer, which is the key serializer and the value serializer. So now we need to provide the same object, well, like 2 objects, key value of type string. So this is how it works. I will show you later on when we want to use Json, for example. So here it will be the key is of type string, and also the value will be of type string. Let's call it Kafka template. And now, so we don't need to create manually the constructor since it will be provided by this annotation. So now I want to create a public void. So I will call it, for example, send message or publish message. You can call it anything you want. And for this, I will ask to get a parameter of type string, and I will call it message. And then all I need to do is to call my Kafka template and then send. So this send, we have like several implementation or several override method. As you can see here, we can whether send the message or topic and the message, producer, record, and so on and so forth. So for our case, we need to provide to which topic we want to send our message, and then the object or the message we want to publish. So the topic, it's Alibu, as mentioned here in this configuration. So you need to be careful, don't make typos, otherwise you might have exceptions. So here, just before that, I will inject here my annotation slf4j in order to have a logger, and I want to log.info, and then I will use string.format, and then for example, let's say sending or message sent, for example, sending message to Alibu topic. And here, let's say, for example, this is our message and it will be %s, and here we can concatenate with MSG. Also, if you want to, we can also add static import to this one. So here you know that this format is coming from the string class. So now we have our producer. So this producer is able to send or to queue a message to our Apache Kafka server. All right, now let's go ahead and create a REST controller in order to be able to call this Kafka producer. So I will create a new class and I will call it, for example, in REST, or you can call it controller, whatever you want. Just feel free to name your packages and classes the way you want. So here I will just call it message controller. All right, so here it will be REST controller. And then I want to have a required as constructor, and also I want to have a request mapping for my controller. So I will call it /API and then /v1, and for example I would say messages. So here I will need my private final Kafka producer, and then let's call it Kafka Producer or just Producer, and then I will create just a post mapping since we want to post something. So here we have a post mapping, and then it will be a public response entity, and let's say, for example, of type string. So here I will say, for example, send message, and then let's ask, for example, for a request body, which will be just a string, and then let's call it message. So for our message, then what we want to do, all we need to do is first calling our Kafka producer and then send message, and let's pass the message as a parameter, and then let's return a response entity dot OK, for example, and here we can say, for example, message queued, and we can add it, for example, successfully. All right, so here we have our message and we have our REST controller. Now, before going and moving to testing, let's just try to start our application and see what will happen, if everything is fine or if the application starts or not. So here we see that we have a bunch of extra logs. So this is coming from the configuration that we provided for our Kafka, and also from creating the topic, the configuration to create the new topic. So as you can see here, we have the Bootstrap servers, we have the configuration that we provided, and also this is the configuration or the default configuration from Kafka. So if we scroll to the bottom, here we see that the application already started. Now let's go ahead and test this application or test this small API. So before we move on and start testing, let's first open our terminal, and now let's navigate to our server. So here I will just navigate to our Kafka server, and now let's go back to the documentation. And as you can see here, in order to read an event, we need to run this command line. I will copy it and then I will paste it in here. So let's change the topic name, since our topic is called now Alibu, the one we just created within our application, and let's hit enter. So far we don't have any messages consumed or queued to our application. So now let's open Postman and let's send the first message. So here I prepared already the request for you. So all we need to call is HTTP, and then our application is already started on the port 8080, and here our API is //API/v1/messages, and here we want to send a post request, so we need to provide a body. So our body will be of type row, or will be row, and the type or the content will be of type string. So here let's say this is my first message to Apache Kafka. All right. And then let's click on send and see what will happen. So we have 200 in here, and also we have the message queued successfully. Now if I go back to our IntelliJ, so we see here that our consumer already consumed this message. So again, if we go back and we send another message, so let's say for example here is a new message, and we hit or we click on send and we go back again to our terminal, we see that we have the message right here. So this way we are able to send a message to our queue from our producer. Now let's move on and let's implement a real consumer for our topic. All right, now let's create our consumer. First of all, I will stop this consumer from consuming the messages, and I will also stop the application. So now let's open here and let's create a new class, and in a new package I will call it consumer, and then I will call it, for example, Kafka Consumer as my consumer class name. So this one, of course, we need to mark it as a Spring component, so let's give it the service annotation. And then all I need to do is to create a public void. So this is our method, and then let's call it consume message, for example. So let's call it consume MSG, and then what we want to consume. So we are already publishing or pushing a string message, so we need to consume a string message. All right. So now before that, let's use our SLF4J annotation in order to have our logger. So let's say our log.info. And here, for example, let's use again our string.format method. And here, let's say consuming the message from Alibu topic. And let's say here, let me add a space. And here, let's also concatenate our message. So %s, and here it will be MSG. All right, we can also statically import this one. And now what I need to do is simply add an annotation in order to tell Spring that this is a Kafka listener. So as I mentioned, the name is already Kafka listener. So within this Kafka listener, we need to provide a bunch of information. Well, not a bunch of them, but at least we need to provide 2 or 1 minimum information. So the minimal one is the topics. What are the topics that we want to consume? And in this case, we want to consume our topic called, or we named it Alibu when we created our topic configuration. And then, since here in this configuration file, we said that we want to have a group ID, and we called it my group. So here we can also provide this information to this Kafka listener annotation. So here we have a group ID, and let's say that this listener or this consumer is part of this group ID. All right, so now we just want to consume a message and see that this message is just running. So now just make sure again, our consumer, the one provided by Apache Kafka, is already stopped. And now if I run the application, we will see that the consumer or this consumer will be logging this information or the consumed messages. So let's start our application and see what will happen. So, all right, so here we have our application running, and we already see some logging from our Kafka consumer. So here it says consuming the message from Alibu topic. So this is the first message, and here is the new message. So now let's send another message. So this is a message to the consumer, and let's click on send. Now, if I go back to the browser, we will see that we have a new message logged here. So here we have consuming the message, and this is the message to the consumer. If we send another one, it will be also logged in here. So now this is how we can create a consumer for our application. All right, so now what if we want to send JSON data format? So first of all, Apache Kafka stores and transports data in a byte format. So there are numbers of built-in serializers and deserializers, but it does not include any for JSON. And the reason that Kafka does not provide a JSON serializer is to avoid imposing a specific serialization format on users. So Kafka is designed to be agnostic to the data formats used by producers and consumers, allowing flexibility in accommodating various data structures and serialization formats. But Spring Kafka created a JSON serializer and JSON deserializer, which can we use to convert Java object to and from JSON. So what we will see, so we will send a Java object as a JSON format from the consumer, and it will be from the producer, and it will be consumed by the consumer as also a JSON format. So we will see how we can configure our application or our consumer and producer in order to send JSON and to receive JSON. So the first thing we need to do, we need to go and update the configuration. So let's open our application YAML right here. And here where we have this deserializer for the consumer and the serializer for the producer, we need to introduce a small change right here. So the change is we need to tell our application which serializer and deserializer we want. So I will just duplicate this one and comment out this line. So here, instead of using the org.apache and so on and so forth, we have another implementation. We said org.spring-framework.kafka.support.serializer. We have a class called JSON deserializer. So this is the class for our deserializer. We will do the same for the serializer. So I will duplicate this line, comment out the old one, and just change this path. So this one should be JSON serializer. Let me remove this, and here we need to talk about serializer, not deserializer. And of course, don't forget to remove the D from here, so it's value serializer. All right, so next what we want to do, we want to create an object that we want to send from our consumer, from our producer, and consume from our consumer. So here I will just create a new class. In a package, I will call it payload, because when we send something, we call it payload, and I will call it, for example, student. So I will send a student object having, for example, private int ID, and for example, private string first name and last name. So this one also last name, and we can use the Lombok annotations to create getters and also setters. And we need the all args constructor and no args constructor, but we can skip that since it's already, we have our default constructor there. So now the next step is, let's see how we can, or like, do we need any configuration to send and receive JSON format? The answer is just in few seconds. So after changing the configuration, the next step is to change our producer. So here we have the example for a string producer. Let's keep it that way, and I will create a new one. So I will create a new class, and I will call it Kafka JSON producer. So like you can have, and you will have the whole code for everything. So the first thing, of course, this is a service, and I need my required args constructor in order to inject my dependencies. So again, we need our Kafka template. So here I will do private final Kafka template, and now it will be a string for the key and our object as the value. So our object is the student, so it will be student. Let's call it again Kafka template, and now I need a public void, and let's call it send message. So to send the message, what we need our student as object. So let's call it student, or simply data, or let's call it simply student. Alright, so after that, what we need to do, really just as we did with the Kafka Producer, just Kafka template.send, but it's not the case. So here, what we need to do, we need to create an object of type message. So here I will create an object of type message, and it's coming from the Kafka package. So you need to be careful about this. So this message will be of type student, and then I will call it message equals message builder dot, and then we have a method called write payload. Sorry, not write, but with payload. And I guess I imported this message from the wrong package, but we will see. So here we have with payload, and our payload is the student object. So next we have to set the header. So we can set header or headers. So our header is the Kafka topic. So we have a class called Kafka headers dot topic. So this is the topic, or like the object that we want to send. We want to specify to which topic we want to send this one. And our topic, as we mentioned before, is called Alibu, and then dot build. Alright, so here this build method, it will return an object of type student, and here we can make sure or check which package is this one. So yeah, when we imported our message class, we imported it from the wrong place. So it should be org spring framework dot messaging, not the one from Kafka. So let's change this one. So we can remove this import from here, and we can import the new one. So it's the correct one is spring framework dot messaging, and as you can see, it's a generic type. So in this way, we are able to send our message, but here we just built the message. We need now to send it. So now we need to call our Kafka template dot send, and as you can see, the send, it also like we have a send method that takes a message as an object. So here we want to send our message. All right, so this is the method that we are talking about. It's a completable feature, and it takes the message as an object. All right, so this is the send method. Now let's move on to the next step. All right, now let's adjust our controller. So the first thing here, we have one Kafka Producer, which is a service, and we have the new one, which is also a JSON, the Kafka JSON Producer, which is also a service. So when I come here to the controller, we might face like an issue that we cannot know, or we don't know which one to inject. But here we have like the Kafka Producer. So here we just need to change this one to the Kafka JSON Producer and consume that one. All right, so now I will adjust this method. So I will just duplicate this method here, and I will call it send JSON message. And here instead, I will ask, or I will require a student object. And here for this send message, I will just inject the new Kafka JSON Producer, and I will call it Kafka JSON Producer. All right, so now instead of using the Kafka Producer, let's use the Kafka JSON Producer, and let's send the message. So here also we can return send queued successfully, and let's say as JSON, just to differentiate between the two different methods. So here we have a post mapping, and now I will just add a small thing just to differentiate it. I will just add /JSON to know that we are calling the JSON method. All right, so this is just for a test. It's not the best way to inject two services doing almost the same thing. We need to separate them or use one of them, but it's just for the purpose of learning. So now we even have our consumer right here, so it will consume this topic, and now we can just go ahead, start the application, test it, and we will see how this message will be displayed. So will it be displayed as a string, or will it pose an issue since we have a JSON deserializer? So let's go ahead and check that one. Otherwise, we can also create or change our Kafka listener accordingly. All right, now let's start our application and test again and see, as we mentioned before, if our application or our consumer is able to handle these messages. So first we see that we have some exceptions while starting the application. So let's investigate this exception. So it starts from here. So we have error handler cannot process the serialization exception. Let's check the coast by, and here it says error deserialize key value for the partition alibu 0 and so on and so forth. So if we scroll also down, we see here that we have a different cause. So it says that the class com.alibu Kafka payload student is not in the trusted packages. So this means, and here it mentioned that if you believe this class is safe to deserialize, please provide its name if the deserialization is only done by trusted source. You can also enable trust all with a star. So for that, we need to add one property here to our application in order to tell Kafka that we trust these packages and we want to deserialize from them. And specifying a trusted packages in Kafka is a security measure to prevent certain types of attacks related to deserialization. So the deserialization process is the process of converting data in a serialized format, such as JSON, for example, back into its origin object from. So the process can be exploited if not properly secured. That's why we got this problem. And now to fix it, we just need to add one property. So here within the consumer, we can say properties, and then we have one property called spring.json dot trusted packages, trusted and then dash packages. And here we can whether just provide the package as mentioned in here. So it says that this package is not trusted. So we can whether provide a single value or like a list, like we can provide multiple values or multiple packages, or if you want, you can allow or trust everything by providing a star in commas. In colons, sorry, not commas, but a star in colons, and now we will be able to trust this package. So let's start our application again and see if this property works. So I will start the application, and now let's see if we have something different. So yes, we have something different, and here if you scroll down to the logs, we will see that we have now, this is our deserializer. And also now we have a different exception. So let's go down to the coast by, and here we see that cannot convert from student to string. So this means that we are not able, or our consumer is not able to deserialize or to transform the JSON object to a string object. So we need to adjust our Kafka listener. So let's go ahead and do it. So now within our Kafka listener, we can whether just adjust this method or create a new listener. So we can create another one, and I will just comment out this annotation. I just don't want to use this one. So here I will just call it consume JSON message, and now all we need to do is to provide the type. So here it's of type student, and let me rename this one, and now I'm gonna call it student. So here automatically Spring will be able to deserialize the object that we will receive into a student object and print it in here. So here let's just also call the toString method, and that's it. So this is how we can adjust, or this is how we adjust our Kafka consumer. So also I could just create a Kafka JSON consumer and like listening to the same topic, or even going here to our Kafka topic and create a new topic, for example, calling it alibu JSON in order to consume it. And of course, we need to adjust our JSON producer to send to this new topic, but I just wanted to keep it the same way. So just here to explain to you that you have multiple options. So now coming back to this one, so here this is the small change, and now if I restart the application and see the changes or the impact, so here let's close this one, and now I will go back to Postman and send again one message. So if I open back my console, so here we should see something. So consuming the message from alibu topic, and here, so this is the object. So here it's just because I don't have an implemented toString method in my student class. So if you want, we can do that quickly. So here we can also call the toString method from Lombok, or annotation, sorry. And now if I restart the application and send again another message. So if I click on send and I go back here, we see here that we have the object, or the object just getting printed. So if I send again another one, so let's say John, for example, and here John Doe. And if I click on send, we should also see again that we have this John Doe getting printed right here. All right, so now our consumer works. So now the best parts begin right now. So now we will move to the implementation of our real world application. So the real world example, and we will be implementing a really cool application using Spring Reactive. All right, now the best part begins. So this is a global overview of the project that we will be building together. So let's start from the left hand side. So first, we will create a Spring Boot project, and this will be our producer. And this producer will have an API where we can invoke or even start consuming a stream of data coming from a reactive REST API. So this reactive REST API is the stream of the Wikimedia. And I will give you an overview also about Wikimedia in just a few moments. So also you can see the link is in here, and I will also put it in the description of this video. So here our REST API or our reactive consumer will consume this data. So here we have a consumer of our reactive REST API coming from Wikimedia. And this REST API or this consumer will call the producer that will publish all these events to our Kafka cluster. So this is the cluster, and we have like the brokers, topics, partitions, and so on and so forth. All the things that I already explained before. And from the other side, like the consumer side, we will also have another Spring Boot project, and this will be our consumer. So the consumer will subscribe and listen to all the messages coming to a specific topic. All right. And then afterwards, here I will just not implement this part. I will just be logging the data, but here feel free to do whatever you want with the data you have here. So you can, for example, persist the data to MongoDB, PostgreSQL, an S3 bucket, or any other storage system. All right. So here, like, I will leave you the chance, and also I would like to see what you will be doing and how you will implement that. And I would love to see your comments on the video, and also if you want, just publish the code on our Discord server, and I will be happy to review it and give you my feedback. All right, so also here you can picture these two services or these two projects as two microservices communicating together through a Kafka broker. All right, so now let's go to this one. So first of all, let me give you an overview. What is Wikimedia? I think Wikimedia is something that's related to you when we say Wikipedia. So Wikimedia is a group of all these services we have right here. So this is like Wikimedia is a global movement whose mission is to bring free educational content to the world. So like it's Wikipedia, Wiktionary, Wikibooks, and so forth. And this stream Wikimedia is a stream that represents all the changes that are made by the community on the Wikimedia projects. All right. And in order to see that, so here we have this link. I will paste it in here. And now I will just refresh the page. So you see here, so if I scroll down, it's a stream of data. So every time I scroll, I will see data. So if you want also to understand and to have a look about Spring Reactive or like reactive REST APIs, I would love to invite you to check the Spring Reactive course that I published before on my channel. So I will leave you also the link in the description of this video. So here we see the data. Maybe we can also zoom in a bit and see what are the data is. So here we have the topic, we have the schema, and we have so many information. We can also go and see this in details later on. So just to give you an idea about the stream and the size of the stream that we will receive from these endpoint. So there is an open project. It's called, I will also leave you the link in the description of this video where you can see an overview. So here we see that we have a stream of 68,000 and it's still growing. So this is a huge stream. And in order to be able to process that, we need also a really strong and scalable and powerful message broker like Apache Kafka. So here, this is a dashboard and you can have a look on it to see all the data and what are the streams. So here, for example, we have all these events, we have the size of the edit, and we have how many records are displayed. So far, like since switching to this tab, you see that we got more than 1,000 records. All right. So this will be the parts or the building blocks of our application. Now let's move on to the next part and start building this project. All right. So now let's go ahead and create and configure our two projects. So first it will be a Maven project. And here for the group ID, it will be com.alibu.wikimedia, for example. And now to differentiate the two projects, here for the artifact, I will add this one for the producer and I will keep it this way. So now let's go ahead and add our dependencies. So first we need our Apache Kafka, and then we need our reactive web. So here we will not be using a classic Spring web annotation, but we need a Spring reactive in order to be able to consume a reactive API. And then of course we need our Lombok annotation. So this is the first project. Let's go ahead, click on generate, download it and also import it in your IDE. And let's also create the second project. All right, so after downloading the first project, now let's change this one to consumer. So this will be our consumer project. So for this one, let's remove the Spring Reactive Web. Maybe let's have, for example, just Spring Web in order to, if we want to add some API, but for now it's not the plan, but maybe later on. All right, so this is our second project. Let's click on generate and let's open both of the projects in our IntelliJ and start coding. Alright, so as we did before, the first thing that we will do is to just first rename this one to YAML property. And now we can go faster because we can go ahead and copy some properties from this one. So here, let's copy these properties from the producer. And then we need to add spring.kafka and then in this way. So since we are working on the producer, just to bring you back, since we are working on the producer, we can copy paste this one. And also what we want to produce a string instead of a JSON, because like I just don't want to waste your time and creating an object and deserializing the stream or the data that you will receive. I will just instead send it as a string. So first, this is the configuration of our producer. What we need to do next is to create our topic configuration. So now I will just right click and then inside a config package, I will say, for example, Wikimedia topic config. All right, so in the same way, if you want, we can also go ahead and copy this bean. So it's simple even to rewrite it our own, but let's just make it faster and copy this bean from here and paste it in here. And also don't forget to add the @configuration annotation there. And now let's call it Wikimedia and then -topic or Wikimedia stream. So let's call it this way. All right, so now we have our topic ready. Here, let's also rename this one Wikimedia topic or Wikimedia stream topic. And then let's move on to the next step, which is consuming our stream API. So now within our producer project, again in the configuration, and in order to be able to consume a reactive API, first we need to have some configuration. So I will create a configuration class and I will call it webconfig or WebClient config to be more consistent. So this, and here in order to make this one a configuration, we need to add the configuration annotation. And now I want to create a bean, and this bean will be of type WebClient.builder. All right, so this is the web client, and then we have a builder. So let's call it web client builder. So web, and here we simply need to return web client and then dot builder. So this is all we need to do. Now let's move on and create our web client consumer or our stream consumer. All right, now let's go ahead and create our producer. So here, right click, new, and then producer. And then let's call it, for example, Wikimedia producer. So this producer class will be the class as we did before. It's just the class to send a topic to our Apache Kafka. So here we can also go back to our Kafka demo. And here let's go to the Java and then producer. And we need, or we can take this from the Kafka producer. So here we just can copy this one. And also we can copy this. And let's go back to our Wikimedia producer. So we can close this class. And now I will paste the annotations. And then I will paste the code that I copied. So here, like, for example, that we can whether change the log, or we can also remove this one for now. We don't need it. And here we need to rename the topic to our Wikimedia and then stream. All right, so also just to be sure and avoid typos, I will recommend, so let's close the demo. I recommend that you go here to the topic config and just copy and paste the name just to avoid these typos. Also, you can create a variable for that and use it everywhere. All right, so this is not that important, but just you need to make sure that you don't make typos just in case. All right, so now we have our producer ready. Now let's move on and create the stream consumer service, the one that will consume the stream API, and then it will publish the message to the Kafka topic. All right, now I will right click here and create a new class, and I will call it, for example, the stream or Wikimedia, or you can call the package whatever you want. And here I will call it Wikimedia stream consumer. So this one will consume to our stream coming from the Wikimedia. Let's make this one full screen. And first of all, we need to make this a service. And then let's say, for example, SLF for J. Just we want to log what we have. All right, then what we need to do, we need to inject our web client. So private final and then web client object. Let's call it web client. And then we need, of course, our private final, and then we need our Wikimedia producer. So let's call it producer. And now let's create a constructor with these two parameters in order to inject them. Now we need to make some small changes. So here, instead of the web client, we need the web client dot builder. All right. So because this is the bean that we created in our configuration. So here instead, what we want to do, this dot web client equals this builder. So let's also rename this one to builder to be more consistent. And here equals web client builder and then dot base URL. So we need to set our base URL. So the base URL for us is the stream.wikimedia.org/v2. So this is our base URL. And then we need to call, of course, the build method. So let me maybe break this down so you can see everything at a glance. So this is how we can configure, or how we can configure our web client object. So now the next thing we need is we want to create a method. So it will be a public void consume. So let's call it consume stream and publish. All right. So this consume stream and publish will consume the stream coming from this API and then publish it to our producer or to our Kafka broker. So what we need to do here, we have our web client and then it's a get method. So .get, and then we need to pass the URI, so the rest of the URL that you want to consume. So it's /stream and then /recent changes or recent change. All right, so this is the endpoint, and then what we want to do is to retrieve, right? And then we wanted to body to Flux. So we want to transform our body to Flux, and the format is string, right? So this is what we decided. We said, okay, we want to consume and to produce a string, and afterwards how we can still consume what is coming from here. So it's the publish subscribe pattern. So that's correct. We need to subscribe to it. So after subscribing, let's maybe try a system and then .out just to print, or let's say for example log and then info, just to log what we have in here since we injected our logger here. All right, and then we will change this one to send the data to the producer. So what comes next is we need to create a REST API which allow us and help us just to trigger this consumption of the API and sending the data. So let's go ahead and do it, or you can also do it in this place by injecting a command line runner bean and just trigger this consumer. But let's make it as a REST API. That will be better. Perfect. Now let's right click here and let's create a new class. Let's call it maybe REST, and then let's say for example Wikimedia controller. All right, so this one I want it to be a REST controller. And also I want my required Args constructor and my request mapping. So the request mapping, I will call it /API/v1/Wikimedia, just to make it simple like that. And then what we need to do, we need our consumer. So let's inject private final, our Wikimedia stream consumer. Let's call it consumer, or let's call it stream consumer to be more consistent. So now all I need to do is to have a get mapping and then public void, and then let's say for example start consumption or start publishing, since the main goal is to publish this stream to our Kafka. So start publishing, and then we require nothing. So here let's make it a void, or you can also say a response entity of type void or of any type, and then just return some message or some confirmation. All right, so but the most important here is we want to call our stream consumer dot consume stream and publish. All right, so this is our API. What we need to do, or what we want to do next, is to start the Wikimedia producer application, and we need to see that we are consuming the stream from our downstream API, and we need it to be logged in our output console. So let's go ahead and do that. All right, so to do that, whether you can click here on producer application and run it from here, or also within IntelliJ you have the option services, and then you have all the Spring Boot applications available in your workspace or in your project right here. So for our case, we want to start the producer application, and I will start it in debug mode. Just in case if something happens, I want to go back and be able to debug. So also you see that the configuration for our Kafka is working, and here we see that we have also this output for Kafka. So first I will clean this one, and then what I will be doing, I will open Postman and send a GET request to this API. Let's just change the URL right here, and it will be a GET mapping. So we have nothing in here, and I will just click OK. So it's 404 because we have a typo here, and let's click send again. So it's 200. Now if I go back to our console, I expect to see that we have a stream of data. So this is what we see. So we have like the Wikimedia stream consumer, and it's consuming this API. So as you can see, as I scroll down, it will continue printing the data. So we are streaming the data, or we are reading or subscribing to that stream API. So now let's go ahead and enable our producer in order to publish these data or these events or this information to our Kafka broker. And to do that, we just need to go back here, and here instead of logging, let's say for example producer, and then send message. So we can use this method reference, since the send message also takes a string as a parameter. Also, you can re-enable the logs right here, but this should be also fine. Now, if we restart the application and send, we should be able to have the data published to our Kafka. So let's keep it for later on when we run the whole application. Or you can also, let's also give it a try. So here, if I open back my terminal right here and I try to consume the topic that we have, or the topic that we created, which we called our Wikimedia, and then dash stream. All right, so I will just hit enter here in order to have the stream ready. And now I will go back to our Postman and just hit enter. And here I'm expecting to see the data starting popping up. All right, so my bad, I just restarted the wrong application. So I will stop this one and I will click on service again. So here we have our producer. So this one, it's already stopped, and let's restart our producer. All right, so the producer is up and running. And now if I open back the terminal and I click on send again, so this one is running and I'm expecting to see a data right here. So this is what we are seeing here. And if I scroll down, the consumer will keep consuming the data. So now, like, the good thing, we are successfully publishing data. And so far we published 401 messages. Okay, so now, so the producer is up and ready. Let's move on and create and implement our consumer and have the application fully up and running. All right, now let's go ahead and do the same thing with our consumer. So the first thing we need to do, I want to rename this one or change the extension to YAML instead of properties. You can also use properties if you feel much comfortable with that. And again, I can also copy these properties from here. So let me copy all this configuration for our consumer and paste it in here. So now I just want to bring back that I want to consume my string, or like I want to use the string deserializer instead of the JSON deserializer. Also, here we can even remove this one since it's not needed because we are just consuming string messages. So, but I will leave it in the commented here so you can use it later on. And also, this is our group ID. You can change the name if you want to use a new one. And here we can keep the same configuration. And of course, our Bootstrap server is also the same. So the next step is, let's go ahead also and copy the configuration from our producer, the one that we use to configure our topic. So here's just, we need this one, Wikimedia topic config. And let's also bring it here. So here you might say, okay, but this is the application. The answer is not. This is not the application because it's just the application when you duplicate the code. But otherwise, this one is not a duplication because these two services are supposed to be separate services. All right. So here I will also create just my consumer package and then Wikimedia consumer, and I will come back to it just in a few seconds. Also, I want to move this Wikimedia topic config. So like there is a cool way to do it within IntelliJ. So here within the package name, you can just add .config at the end, and then IntelliJ will propose to move this package. So here, if you use the auto completion, and it will ask you to move the package to this new package. All right, so here, all right, so now we just moved this configuration there. Now I will close all this, and here, like, the consumer part is the easiest one. So all we need to do is to create our consumer. And in order to do that, we can also go back to our Kafka demo and we can copy the code from there, just not to waste time on something that we already saw together before. So now all I need to do is to copy this code right here. And let's go back to our consumer. And here, let's make this one a service. And then also I'm going to use SLF for J, and I will paste this one and re-enable this annotation. All right, so it's a Kafka listener, and here we need to use the same topic. exact. So let's close this demo right here and let's go back. So this is our topic name, which is Wikimedia stream. So now going back to our consumer, let's give it a name. And also, if you changed the group ID in the configuration, please make sure that you change it in here. So now let's say consuming the message from Wikimedia stream topic, and then let's also log the message here. So now that's it. Normally this is all we need to do for our consumer because we just want to consume. And also here, please, I'm going also to leave it as a comment. So please feel free to do anything you want with the data. All right. So I would just leave it to you. And as I mentioned before, I would like you to implement something and also share the links, the GitHub links with me, and I would be happy to do a code review for you. All right. Now what we need to do next, we need to start the two applications and see once we start consuming or once we start producing and pushing data to our broker, we need to make sure that we are also consuming it from this part. All right, so now the first thing that I will be doing is to start my consumer. So this is the consumer application. I will start it in debug mode and see if everything is fine. So now let's see, we have already we are consuming already some data. So this is because we have already some queued messages. Now, if I start my producer application, so let's start the producer and then let's just invoke the endpoint, and then we will see that, okay, so yeah, that's fine. We are not able to start the producer because both applications are running on the same port. So let's go to our producer and go to application properties or application YAML, and here at the end let's say server.port and let's say 8081 for example. All right, so now I will restart the producer and now it should be up and running normally without any issues. Okay, so the producer is also running. I will clean the console and then I will open again Postman, and here I need to change the port and send again the request. So here we see that we start producing the data, and if I open the consumer, we will see that we are consuming messages. So this is what we see right here. So the consumer is up and running, and here we are consuming the data coming from our producer. Now, if I stop the producer from sending the data, you will see that the consumer will no longer receive any other messages, so it stops printing the data. That was it for today's video. I hope you enjoyed it, I hope you liked it, and I hope you learned from it. Now, if you're satisfied with the video, I would like to invite you to do a few things. First, if you're not subscribed, just go ahead and hit the subscribe button, enable the ring bell so you will no longer miss any of my coming videos. I'm really preparing a really nice and exciting content for you guys. Then, if you don't know my website, just go ahead, check the alibocoding.com website, check the courses that I have there, and enjoy learning. Finally, if you are not connected with me on social media, just go ahead and do it. You will find all the links in the description below of this video. Thank you so much for watching, and see you next time.